Assalamualaikum and hi everyone. We are group 2 from class 1E and our program code is CEEH 110. In this video, we will be presenting about the application of derivatives in chemical engineering. So this is our group member's name and our student ID, starting from Nurfara. The second one is Akila. The third one is Najiha. Next is Faisal and the last one is Halif. So this is what we are going to discuss in this video. We start with derivatives as a general introduction, followed by the application of derivatives in chemical engineering. The next one is the problem statement and we come out with the solution. And last but not least, the conclusion and reference.
Today, we will be presenting about application of first derivative in chemical engineering. Derivative is a function that describes the rate of change of one variable with respect to another variable. Derivatives are an important tool in mathematics and are used in many fields including physics, engineering and economy. The derivative of a function can also be thought of as the slope of the function graph at a particular point. The process of finding the derivative of function is called differentiation. There are different methods for finding derivatives such as power rule, product rule, and chain rule. This rule allows you to find the derivative of many common types of functions such as polynomial, exponential, and logarithm.
In addition to derivatives of single variable functions, there are also multi-variable derivatives, such as partial derivatives and gradient. It is a fundamental tool in the field of calculus and it is used widely in many areas of mathematics and science. Derivatives can also be used to analyze the behavior of a function, such as determining where a function is increasing or decreasing, or where it has a local maximum or minimum. They are also used in optimization problems, such as finding the rate of change. In chemical engineering, we use this method to analyze the flow of the chemical substances in a tank. We have described velocity as the rate of change of position. If we take the derivative of the velocity, we can find the acceleration or the rate of change of velocity. It is also important to introduce the idea of speed, which is the magnitude of velocity. Thus, we can prevent the subsequences of overflowing chemical in the tank.
Assalamualaikum and hi, my name is Nurliana Akila binti Zainuddin and I will be talking about the problem statement that my group have choose for the topic derivation in chemical engineering. So, the problem statement of the volume of azeotrope in V meter cube in a tank container is given by the formula volume equals to pi r square h, where h in meter is the height of the azeotrope in the tank. Azeotrope is then put into the tank at the rate of 35 meter cube per second. Find the rate of changes of the height of azeotrope in meter per second at instant when r is equal to 10 meter. First of all, after we have read the problem statement, what we need to do first is highlight all the main information given to us. As we can see, in this problem statement, it is said that the volume of azeotrope in a tank container is given by the formula V equals to pi r square h. We must highlight this pi because we will have to use this equation when we want to solve the problem later on. And it also said that when the azeotrope is put into the tank, the rate is at 35 meter cube per second. Highlight these two because this is one of the main information that we need to take notes of in order to ease the way solve the problem given to us. Lastly is that they want us to find the rate of change of height of azeotrope in meter per second at instant when r is equals to 10 meter. R here refers to the radius, so we must highlight so that we don't miss all the points when we want to substitute the value of r into the formula given to us, which is for the volume. Lastly, the most important things we need to highlight and take note of is in what unit they want us to give our answer in. And here, they want us to give our answer in the unit meter per second. Therefore, we must highlight this because most of our marks will be reduced if the unit we give in our problem statement or problem solution is wrong. Okay. Next, let us move to how do we solve the problem for this problem statement.
Okay, hi, Assalamualaikum. My name is Nur Najia binti Syamsul Kamal. My ID number is 2022468828. Okay, I will explain the problem solution that Akila talked about. So the first thing, we have to list out the information so we can know what the question wants. So the first information we can see that is a formula of the volume of azeotrope. The volume of azeotrope in a tank container is given by V equal pi r square H. So we have to list out V pi r square H is the formula. So the second information they given is azeotrope is poured into the tank at a rate of 35 meter cube per second. So we know that this is a dV over dt. It's 35 meter cube per second. So the last information given is R equal to 10 meter, which is R is stand for radius of the tank. So what the question one is the rate of change of the height of azeotrope. So which is we can know that the rate of change of the height of azeotrope is dH over dt. So we have to find dH over dt. So the first step is we have to differentiate the formula is V equal pi r square H. We have to differentiate this equation. So dV over dH equal to pi r square. So after we differentiate, we will get dV over dH equal to pi r square. So the next step we have to find dH over dt. How we to find dH over dt? So we have to derive the formula. So the formula is dH over dV equal to dV over dt. But in this question, the question not given dH over dV, but we have already dV over dH. So we have to reverse the question. So we will get 1 over dV over dH. So I have to write here so that you're not confused. dH over dV is equal to 1 over dV over dH. So we can just substitute the equation. Multiply with dV over dt. So we just substitute the information given in this equation. The next step is 1 dV over dH. We can hear is dV over dH is pi r square. So just substitute pi r square. Multiply with dV over dt. dt is already given 35 meter cube per second. In this question, we have to put the value of R. We already know the value of R is 10 meter. So pi R 10 square multiplied with 35. So if you calculate the 10 square, we will get 100. So 1 over 100 pi multiplied with 35. So you just calculate the equation is 1 over 100 pi multiply with 35. So we will get 1.9956. This is the final answer. Don't forget to put the unit. It's a meter per second. Okay. The conclusion is the rate of change of the height of azeotrope is 1.09956 meter per second. So this is the final answer of the rate of change of the height azeotrope.
But not least is the conclusion. Derivatives are frequently used to measure how much something is changing in daily life. They are utilized by the government in economics, a variety of fields, and even population censuses. So like what we have given an example is the application of derivatives in chemical engineering. As an engineer in this field of chemistry, we need to know the process to produce something, the material, and the rate of change of something. The application of derivatives is very wide, so we can use it to solve things like finding the rate of change of a quantity, finding a very small change or variation of a quantity, and calculating the highest and the lowest point of a curve in a graph, or to find out the point of change.